Matric Mathematics and Physical Science students, I need you to please hear me out on something. On your maths paper 1, a lot of your problems get solved when you simplify both sides of an equation until one side is 0 and the other side is the equation. So you add, subtract, you manipulate both sides, you make one side equal to 0, you simplify, you factorize, you find roots, you solve for x. That is what a lot of your maths paper 1 problems are based on. A lot of you don't realize there is a similar protocol for maths paper 2 that is going to help jump your marks up or boost your marks by 20% once you understand this. Because it doesn't look like there is an equivalent of equating one side to 0 or manipulating until one side is 0, but there is. Here it is. In trig, you're working with 90-degree triangles. And a lot of you, you now understand your unit circle, you understand your ratios, you understand your waves. This applies to physics. And then you move over a few questions down into analytical geometry, where you apply your sine rule and your cos rule, and you use SOH-CAH-TOA. Please try switching from SOH-CAH-TOA to shade your rear cos x raised tan your exterior. In other words, you're now thinking about a free-floating triangle in analytical geometry as though it were on a Cartesian plane, where your hypotenuse is always the radius and it goes to an origin point, which is your 0 for your equations. It's gonna take a while. And when you have to calculate areas, lengths, and areas, lengths, as well as angles, please try deriving your sine rule and your cos rule. Each time, drop a perpendicular in a strategic place. Make a habit of finding it and hack the triangle for yourself, where the hypotenuse, you think of that as the radius or as leading to the origin point. Again, you're switching from SOH-CAH-TOA, where the h is a hypotenuse, to shade your rear cos x raised 10 your exterior, where your r is leading you to origin point. And yes, when you're writing your exams, just follow the instructions you're given there and apply your sine rule and your cos rule. But when you are practicing, make a habit of deriving and think of it as like it's on a Cartesian plane. That way, you're treating the triangle, it could be a unit circle. You can rotate it in your head. You will need this for mechanical engineering drawing. You will also just need it for a lot of engineering thinking and vectors and just waves and stuff. But when you're dealing with it in analytical geometry and you think in terms of SOH-CAH-TOA, you're just solving the problem in front of you. You're not developing the habit of thinking relative to an origin point or a 0. That's gonna hold you back, even if it seems to be getting you easier answers up front. It's a big switch, but once you get it right, you will realize that maths is one discipline. And how will it help you with your physical science? And music, by the way. Your piano scales are impossible without Pythagorean theorem and the ratios that come from that. A lot of design principles are impossible without that. When you go to physical science, you shine a light beam through a 60 degree prism, a rainbow comes out. Those are actually two 90-degree angles. That's your 90, 30, 60, 90, 30, 60 degree angles back to back. So the set squares you get in your geometry set are shaped like that for a reason. So from physics to art to architecture and a lot of other disciplines, you're gonna see the same basic shapes and ratios, and in music. But if you're treating mathematics as different disciplines, where in one place you're equating to 0, but you're not thinking in terms of your origin point for your free-floating triangles in analytical geometry, you think you're learning different subjects, and you're not. From your calculus curves to your trig graphs, trig identities, free-floating triangle, and the ratios you're working with, it's all one discipline. Switch from SOH-CAH-TOA to shade your rear cos x raised 10 your exterior. This is in your private rehearsal time. And yeah, so you use that instead of SOH-CAH-TOA and get used to just hack the triangle, drop a perpendicular, derive the sine rule and the cos rule for yourself instead of just applying it, and just when you get to the exam, follow the instructions so that you save as much time as you can.